This video segment, segment 3, concludes the discussion of the instructional activities that comprise part 2 of the coordinating units sequence. It also includes a suggested timeline. At the beginning of video segment 1, we listed the instructional activities in this part of the coordinating units sequence. The first 4 of these activities are conducted in the whole class setting. These activities follow a progression. Initially, students reason by using Unifix cubes as pretend candies. The activities evolve to reasoning without the cubes, with the anticipation activity intermediary in this progression. Imagination bingo is a culminating activity. So far, we have discussed the first activity, reasoning using Unifix cubes. Now we want to explain the progression to reasoning without the cubes and the role of the anticipation activity in that progression. As children repeatedly solve tasks using the cubes to act out the story and to figure out how many candies Mrs. Wright has now, they become increasingly efficient in their use of the cubes. Children that initially counted by ones, even though cubes were already packed into tens in their supply of cubes, shift to being able to use the sticks of 10 as rolls without breaking them apart or counting them by ones. Children such as Joe and Michael and Amber and Tiffany shift to using approaches such as Destiny used early on. And children such as Destiny begin to anticipate the results of their actions with the pretend candies, even before they finish acting out the tasks. At this time, it is appropriate for the teacher to shift to using the anticipation activity. In this activity, the teacher uses her cubes to show, not flash, the initial quantity. After students get out this quantity with their cubes, the teacher then tells the students the rest of the story, either how many more candies are made or how many are sold. She writes down this information for students to see so they can refer back to it if necessary. For example, the teacher might write, makes 34 more or sells 18. Students are then told, try to figure out how many Mrs. Wright has now without acting out the rest of the story with your pretend candies. See if you can figure it out just by looking at what you have and thinking about what you would do if you were to finish acting it out. How many would you have? After the children have had time to figure out the result, the class engages in a discussion of the children's solutions. Children talk about how they would show that more candies are made and how they would pack them into rolls, or about which candies they would give to the customer and how they know how many would be left. The teacher can use her cubes to demonstrate these ways to the class as the discussion progresses. This anticipation activity is a transition activity in the sense that students begin to act out the story but interrupt their acting out activity to attempt to figure out the task just by imagining completing the actions with the cubes. We know that students like Destiny and others like her begin to anticipate the results of their actions when the tasks are posed in the reasoning using Unifix cubes format. The anticipation activity provides them with the needed impetus to advance while at the same time provides those students such as Joe and Michael and Tiffany and Amber the opportunity to complete the tasks using the cubes if they need to do so. We often see children such as these gradually shift from actually using the cubes to complete the task to touching the cubes as they reason without actually acting out the final step of the story. In this way, the anticipation activity provides learning opportunities for children at differing levels of conceptual development to participate meaningfully and to advance in their understandings. As teachers watch how students complete the task, they are able to make informed decisions about when to shift from posing the tasks in one form to another. Often, children's explanations indicate when they are anticipating the results without finishing acting out the story. When a number of children appear to be doing so, the teacher can make the shift to the anticipation task. In fact, teachers often pose 1 or 2 tasks where students use the cubes and then pose the immediately following task in the anticipation format. It's easy to do. After she shows the visual image of the initial quantity, the teacher can say, "This time, instead of acting out the rest of the story with your pretend candies, just think about how you would do it." Those children that are not yet able to complete the task mentally use their cubes. Similarly, after using the anticipation activity for a number of lessons, the teacher can shift to using the reasoning without the cubes activity. Some teachers pose one or more tasks using the anticipation format and then collect the cubes and pose several tasks in the reasoning without the cubes format. In this activity, the teacher poses the task by showing, not flashing, an image of the initial quantity for students to see and then telling the rest of the story, either how many more candies are made or how many are sold. But now, students no longer have Unifix cubes available to them at all. They are expected to solve the task entirely mentally, but with the support of the visual image that shows the initial quantity. Even so, there will be a few children that will need to use the cubes to be able to participate meaningfully. It is important that such children be given the cubes, else they cannot participate in a way that makes sense to them. In first grade classes, there may be one or two children that will continue to need the cubes even to the end of this instructional sequence. As every teacher knows, not all children get to the same endpoint in their learning. One principle that undergirds the approach to instruction we advocate is that every child should have a personally meaningful way to participate at all times. The final activity in the progression of whole class activities is imagination bingo. In this activity, each child has a bingo card and a supply of chips. The teacher shows, not flashes, a visual image of a quantity of candies that represent the initial amount in a story and leaves that image visible as she tells the rest of the story, either how many more candies are made or how many are sold. Children reason entirely mentally using the visual image shown to figure out how many candies Mrs. Wright has now. They cover that quantity on their bingo cards. We suggest using this instructional activity only sparingly and primarily as a way to provide a variety in format. In essence, use it as a game. This activity is only appropriate if all but one or two students are able to reason entirely mentally. Those one or two students can be given Unifix cubes to use. However, if more than one or two children need cubes to participate meaningfully, this activity should be omitted. We remind teachers that the bingo cards should not all be identical, else the fun of the game is lost. We also note that the number of possible choices the teacher can use in creating the bingo cards is very large. For this reason, the teacher might choose to limit the numbers used on the bingo cards, and she should plan to use both makes more and sells some tasks for the bingo game. To make the game move at a reasonable pace, we suggest that there be minimal discussion during this game. There are several pragmatic considerations the teacher should take into account when planning for the whole class activities in this part of the coordinating units sequence. First, always select tasks that require going over the decade. For example, Mrs. Wright has 34 cherry candies. She makes 18 more is a task that requires going over the decade. Children have to reconceptualize the individual pieces, which exceed 10 in total, as a role in some pieces. But the task Mrs. Wright has 34 cherry candies, she makes 15 more, does not require going over the decade. In this task, children consider the tens, the rolls, and the ones, the pieces, separately and do not have to shift between the two types of units. Likewise, a task such as Mrs. Wright has 46 lemon candies, she sells 18, requires going over the decade. Children have to think about using a roll for some of the pieces that need to be sold. But the task Mrs. Wright has 46 lemon candies, she sells 14 of them, does not require going over the decade. Children can think about the tens, the rolls, and the ones, the pieces, separately. They do not have to think about how to use a roll to get some of the pieces they need to sell to the customer. The reason for this requirement that tasks always go over the decade is that the goal of this instructional sequence is to foster children's development of the ability to coordinate tens and ones. Second, when the teacher poses the task by showing an image of the initial quantity, that image should always be in an easily recognizable form. In part 1 of this instructional sequence, we explained why the teacher should use a variety of different formats when using the Candy Flash activity. Here, we are making the opposite recommendation. In Candy Flash, the purpose was to create situations where the children encountered more than 10 ones, individual pieces of candy. In this way, in order to say how many candies there were, they had to think about how to pack up all those individual pieces into another roll. Here in part 2, our purpose is entirely different. The image the students see of the initial quantity is only the beginning of the task. The reconceptualization that requires shifting between tens and ones, between rolls and individual pieces of candy, comes in as children reason about how they would pack up candies in the makes more tasks and how they would unpack a roll to get additional candies in the sells some task. For this reason, it is important that children can easily recognize the quantity in the initial amount. In other words, they should not have to work at figuring out what the initial quantity is. It is for this reason that we recommend that the teacher shows the initial quantity in an easily recognizable form. One way to do so, and in fact this is what we suggest, is to use the standard form of showing the rolls on the left and the pieces on the right, with the pieces shown in some pattern children will recognize. Here we show 2 examples of what we mean. In both cases, children will easily recognize the amount shown. A third pragmatic recommendation is that the teacher takes care to always use the language of makes more or sells some when posing the tasks. Avoid saying that Mrs. Wright adds this many candies or subtracts this many candies. It is important that children not think I'm supposed to add or I'm supposed to subtract. What does that mean? The entire purpose of using scenarios such as Mrs. Wright's candy shop is to promote children's development of mathematical reasoning as an outgrowth of what they would do when acting in a realistic situation. The language of adding and subtracting will come in naturally as the sequence progresses. A fourth pragmatic consideration is an obvious one, but nevertheless one the teacher has to attend to. It is this: when selecting tasks, make sure that the children's supply of cubes is sufficient for the task. So far, we have discussed the whole class activities that make up this part of the instructional sequence. Partner work is also an integral part of this sequence. Our intention is that partner work is used throughout and is part of a typical lesson. Here we show a typical lesson in part 2 of the coordinating units sequence. Typically, the lesson begins with whole class work in which the teacher poses tasks one at a time that the children solve and discuss. Thorough discussions are essential, and as a result, this part of the lesson often takes up to 20 minutes, even if only 2 or 3 tasks are used. As we have already discussed, the nature of the initial whole class activity progresses over time, from tasks where children reason by using the cubes to those where they reason without using the cubes. The whole class work can be followed by 15 to 20 minutes of partner work in which children work with one another to solve tasks using Unifix cubes as pretend candies. A subsequent discussion of 5 to 10 minutes in which 1 or 2 partner groups explain a task they work on concludes the lesson. Allowing for time to get out and put away Unifix cubes and any other materials, this typical lesson will comprise from 45 to 60 minutes time in total. We recommend up to 1 hour daily for math in the early grades. Our experience is that when the lessons are carefully planned and provide variety in format, such as the lesson we have just described here, young children can be easily engaged for up to an hour. Children become very involved when they act out tasks themselves and talk about their thinking and that of others. One way for the teacher to pose tasks for partner work is to write several on the whiteboard. In this case, the teacher should supply enough tasks so that those children that work quickly will not run out of things to do. Every child should have some meaningful mathematical activity to engage in at all times during the lesson. An advantage of this approach is that the teacher can choose tasks based on what has just transpired during the prior whole class activity. If the teacher uses this approach, she has to ensure that children understand that in this classroom, persisting on challenging tasks is valued more than completing a large number of them. In other words, children have to understand that they are not expected to complete all of the tasks, but rather work hard to make sense of those they do attempt. The teacher has to also make sure that the subsequent class discussion focuses on a thorough discussion of one or two tasks and not on checking answers or going over all of the tasks. Another approach to posing tasks is to provide each group with a supply of tasks to work on. An approach that we have found to be very effective is to create a set of task cards. We call these CS task cards that can be used for this purpose. Here, we include one teacher's description of how she used these task cards in her classroom.
After posing a few mix, more, and sell some tasks in Mrs. Wright's candy shop during the whole class activity, I would have my students work with the CS task cards during partner work. These cards have the same kinds of tasks that the teacher used during the whole class activity. The way that worked best for my students was to make one set of task cards for each pair of students. I did this by cutting apart the cards and putting each set into baggies. I explained that now my students could pretend to work for Mrs. Wright in her candy shop and work together to take turns being Mrs. Wright or a store worker and the customer by using the story on each card. They loved doing this. While walking around and observing what children did during partner work, I found a variety of ways that they worked with the cards. Some children talked through the scenario together to figure out how many candies Mrs. Wright would have after making more or selling some, while other children took turns being the store worker and the customer. Each pair of students was given a bag of Unifix cubes as pretend candies. I noticed that during the first several days of partner work, the children used the cubes to act out the story. But after several days, I noticed that some children started figuring out some of the tasks without the cubes, even if they had them. The Unifix cubes were always available to anyone who wanted or needed to use them. The same set of task cards was used every time we had partner work. As I walked around the room to see what students were doing and how they were learning, I noticed that students sometimes worked on cards they had previously figured out. To me, this was not an issue because they didn't always solve them in the same way. In fact, the ways they solved the task progressed over time, indicating their advances in understanding. After partner work, we had a subsequent class discussion of 5 to 10 minutes for one or two partner groups to explain a task they worked on. Sometimes pairs of students volunteered to show and explain how they figured out a task. Other times, I called on one or two groups to explain their reasoning because of what I noticed during partner work. Later, I had the opportunity to work as an inquiry math mentor to collaborate with other teachers new to inquiry math. At one school I worked with, a team of first grade teachers told me that even though their students had worked through the structuring number sequence, they still needed more time with developing grouping strategies for numbers to 20. We developed another set of task cards, the CS Teen cards, for the purpose of giving those students the opportunity to continue developing concepts to 20. That meant that while many students worked with the CS task cards, some students worked with the CS Teen cards for partner work during the same lesson. The CS Teen cards served the dual function of developing concepts to 20 while at the same time fostering development of coordinating units. Both sets of task cards are provided on the website for you to use.
As you can see from this teacher's remarks, the same types of tasks can be used productively for partner work throughout part 2 of the sequence because as this part of the sequence progresses, children make advances in the ways they figure out the tasks. We want to say a bit more about partner work. For it to be a meaningful learning experience for both partners, it is important that children are paired with someone that is at a similar conceptual level. Here's what I mean. A student who has a better developed understanding of tens and ones should be paired with another student at a similar level of understanding. A student with a more primitive understanding should be paired with another at a similar level. The reason is that when students who have widely different levels of understanding are paired together, typically the more sophisticated student tells the other what to do, and that child often does not understand what the other is talking about. Partner work should be a time when each student solves tasks in a way that is personally meaningful to him or her. Teachers should not think of it as an occasion for tutoring. Having said this, it is often not productive to pair the two least sophisticated students together. Rather, pair such students with someone that already has developed a moderate level of understanding. Another activity that we recommend teachers use for partner work during part 2 of the coordinating units sequence is the money trading game, which is described in the notes that accompany this video. Teachers we have worked with have found that using this game very often during part 2 is very productive in advancing children's ability to coordinate units. In this video group, we have described the activities that comprise part 2 of the coordinating units instructional activities. These include activities used in the whole class setting and partner work. Next, we include an overall timeline for the entire instructional sequence, followed by a detailed timeline for part 2. Here we show the general timeline for the entire coordinating units instructional sequence. Activities in part 1 of the sequence involve reconceptualizing a quantity by shifting between units of 10 and units of 1. Part 2 of the sequence is designed to develop children's becoming efficient with reasoning about sums and differences by coordinating units of tens and ones. The activities in Part 2 involve changing the quantity by either increasing or decreasing the initial amount. As the timeline shows, we recommend devoting approximately 3.5 weeks to Part 1 of the sequence and approximately 5.5 weeks to the remaining parts of the sequence. Now let's take a look at the detailed timeline for Part 2. The first 4 of these activities are conducted in the whole class setting. They are reasoning using Unifix cubes, the anticipation activity, reasoning without Unifix cubes, and imagination bingo. Each activity is used for several weeks. However, these 4 activities follow a progression. The overlap in the timeline shows this progression because the nature of the initial whole class activity progresses over time from tasks where children reason by using the cubes to those where they reason without using the cubes. After several weeks of using the first activity, the teacher shifts to using the second activity when she notices that some of her students are becoming increasingly efficient in their use of the cubes as pretend candies. While transitioning to the second activity, the teacher continues to use the first activity in the same lesson to allow her least sophisticated students the opportunity to use the cubes to enact the entire candy shop story. After several lessons of using activities 1 and 2 in the same lesson, the teacher can shift to using the third activity. She then combines activities 2 and 3 in the same lesson for several more weeks. Some teachers may choose to use the first 3 activities in the same lesson for a number of lessons. Eventually, the first activity drops out and the teacher uses the second and third activities in the same lesson for a few more weeks. As you can see from the timeline, eventually the second activity will drop out and the teacher will use only the third activity, although one or two students may still need the cubes to reason with. This gradual shift of moving to the next activity and including the previous activity in the same lesson provides learning opportunities for children at differing levels of conceptual development to participate meaningfully and to advance in their understandings. Teachers use the fourth activity after using the second and third activities for some time. This fourth activity continues through the end of the sequence as teachers use it sparingly to provide variety in format. As the timeline shows, we recommend using the money trading game for partner work during this part of the instructional sequence, in addition to partner work in which children solve candy shop tasks using the Unifix cubes. The timeline indicates when each is appropriate. The money trading game is appropriately used here because it complements part 2 of the coordinating unit sequence. We note that materials needed for the CS task cards and the CS teens cards are available on the website.